Okay, so we are going to pick up with day 2 of chapter 9. I am predicting a day 3, but I'm not entirely sure, so we will see how it goes. I was able to get all of the notes prepared. So, um, let's do some conversions real quick. They'll be pretty easy. The first things we're going to do is we want to figure out the official width of a football field. If it's given in 160 feet, what is the width in yards? The second thing we're going to do is a Burgundy style barrel holds 228 liters of wine. What is the volume in quarts? And then a person drives a car at a speed of 50 miles per hour. What is the speed in 50? Nope. In 50. Oh my goodness. In feet per minute. Wow. You can tell I did not do my examples out loud today because, talking to myself would probably be pretty weird. So my mouth has not been working right now. Americans consume an average of 18.5 gallons of coffee per year. What is the consumption in cups per minute? So we are going to go over into the whiteboard, but I did want you guys to see what we're doing before I just go writing like crazy. Okay, so for part A, we're looking at, this is example 10. Oh, where did my stuff go? Oh. Right, this is example 10. And part A, we're looking at if we're given 160 yards, where do we want to go to? What do we want our answer in for part A? Oops. I guess that's what we want our answer in, don't we? So feet. And we're trying to get to yards, right? All right. So from that conversion slide, can anyone tell me what we know about feet and yards? Go ahead, Cody.
We know there's 3 yards in or no, it's 3 feet in 1 yard. So, you have 160 feet, and then 3 of those feet will equal 1 yard.
Yep. So we're gonna do what's called a unit conversion. You know how sometimes people love to say, well, when are we gonna use this? I actually can tell you when you're gonna use this. You will use this conversion, not like every single conversion, but you will definitely use this idea of balancing and converting in chemistry. You do something called balancing the equation, and pretty much it takes you from one element or couple of elements to a solution. And if you don't really understand this process in algebra, then when you get to balancing the equations, you're gonna sit there and go, I don't like it. What do I mean? So this is definitely things that you need to pay attention to because obviously it's going to come back up again. So we get 160 divided by 3, and that will give us 53 and 1/3. You could have the decimal version if you really wanted to. It doesn't matter to me. They do that a lot in this section. They'll give you either the decimal version or they'll give you the fractional version, and I don't care which way it goes. It is what it is. I'll figure it out. If you give it to me one way and I have it the other way, I'm capable of figuring it out, so it's fine. All right, so we have 228 liters. I'm gonna help you guys out and put liters on the bottom. Where are we heading to though? Where do we want to go from? We want to go from liters and get to quarts. Very good. So can anyone tell me anything about liters and quarts? so that shouldn't be a 1. What do you guys know about liters and quarts?
1 quart is equal to approximately 0.946 liters.
There we go. So, and much like in chemistry, if you can cross out your units and you're left with the desired unit, then that's kind of like an internal check that you're doing it the right way. 946. Okay. So if you do this in the calculator, 228 divided by 0.946, you will end up with 241.01 quarts. Now, obviously, you guys know these are application problems, so you want to be writing a sentence for each of these, but I'm going to assume that you can do that on your own. Okay. So C, we started off with 50 miles. In 1 hour, and we want to actually get to 2 different things, right? We want to get to feet per minute. Now, my being human showed a lot on my my scratch paper that I'm gonna end up putting up for you guys. So I'm kind of using it as a learning lesson as well. Pay attention to the problems, pay attention to what you're being asked for, because I definitely was like, oh, feet per second, that makes sense in my head. So I'm sitting here trying to figure out feet per second, which would really only be just an extra conversion, but I didn't need to do it. And then of course my problem was wrong, so I didn't know what happened. But if you pay attention, that won't happen to you. All right, so for 1 hour, we have how many minutes?
60.
Yep, 60 minutes. And if we wanted to get to seconds, not that we do, but if we wanted to, we would just then multiply by 1 minute over 60 seconds. I'm sure you guys could do that. There's another conversion that does it a little bit quicker, but you can do it this way too. You can break anything up, honestly, if you know the conversion rates. All right, so there are 5,280 feet in 1 mile. I do apologize if I'm going a little bit quick today. I will obviously stop when you guys, tell me, all right, I've had enough math. We need to take a break. But if we can get through a good portion of it, then it'll definitely help us out. Not that I think spending 3 days on a chapter is too bad, but that won't be terrible. All right. So the answer we get out is 4,400 feet per minute. And then part D, what are we working with in part D? Somebody remind me. What do I want to start with?
Gallons.
Yep. We're doing 18.5 gallons of coffee. And it's actually per year. So again, we're going to have 2 conversions because we want to end up with cups per day. All right, so we're going to have to actually do 2 conversions again. So what's one of the conversions you can tell me about? Actually, we'll have 3.
1 gallon is equal to 8 cups.
Okay, so, oh, okay, so you combined it. I'm all right with that. Is it on the conversion sheet?
No, I just looked at, like, there's 4 cups in 1 quart, and then I looked at the, oh, whoops, I did it wrong. 4 quarts in 1 gallon.
That's all right. All right, I just wanted to know where you were. It actually would work out. I just wanted to make sure that everyone would know it. So we'll go with the everyone approach. So 4 quarts in 1 gallon, but we don't care about quarts this time, right? We care about cups. So now we have to go from, now that we've gotten from gallons to quarts, now we want to go from quarts to cups. So now we have 4 cups to 1 quart. All right, so the quarts cancel, the gallons cancel. We're looking good, but we don't want cups per year. We want cups per day. So what's our conversion from years to day? Year to days. One year is how many days? Normally, typically.
365.
Yep. All right. So if you go ahead and plug that in, you'll get 18.5 times 4 times 4 divided by 365, and you're going to end up with 0.81 cups per day. Okay, or cup per day. Now, it might not seem like a lot, but I can probably tell you that's probably not accurate anymore. And I mean, I don't know, I guess that just says something for Americans anyway, because we probably prefer energy drinks. I do. So, which if I was a commercial right now, I would apparently be sporting whatever the heck this company is. So, haven't tried it. Hopefully it won't taste like junk. All right. So that is the end of 8.2. I know I probably could have stretched it out yesterday, but I just felt like you guys probably had enough examples yesterday, and I was okay starting it today. All right, so now we're going to move on to example 11, which starts us with 8.3. And the only reason I'm really telling you guys the sections at this point is because with me not being able to get it done in 2 days, presumably, I just want you to make sure that if you are able to stay up with your homework, you know what homeworks you can do. Okay, so there's a couple of examples within example 11. The first one deals with same denominators. So when you look on my scrap paper, you're going to wonder why I went through and factored, and that's because I am just kind of trained at this point that when I see something like this, I'm going to factor it, but you actually don't need to, and I will explain why when I'm done writing it out. Okay, so much like with regular fractions, in order to add or subtract them, we typically have to have the same denominator, right? That's like the first goal. You have to get them so that you can add and subtract them and whatever. Like I said, when I looked at that, I was like, oh my goodness, I need to factor it. I actually didn't have to, so I did an extra step and then kind of got cranky with myself. So literally this problem is a little bit easier than you would think. We're going to just rewrite the denominator once. So that's on the bottom. And then we're just going to combine our numerators. So x squared plus 5x plus 6. Now is when we want to come in and factor. And someone or multiple someones might be wondering, well, what's the point of factoring now? You already have it combined. But I'm going to tell you that once we have this factored out, what can you tell me? If I wouldn't have factored, would we have just said we were done? Would you have been like, oh, well, looks nice, it's pretty, you know, doesn't make me cringe? But if we factor, what do we realize happens?
The x plus 3 cancels out.
Excellent. Okay, x plus 3 cancels out. So we're left with just an overall answer of x plus 2 over x minus 3. Now, if you don't go through and do that cancellation, guess what? Pearson says you screwed up. You didn't get it. You didn't get the answer right. You didn't get a half right. You're just done. So now you're sitting there going, I don't know what I did wrong. So if you're sitting there going, I don't know what I did wrong, the first thing you should look at is, did I factor completely? Did I simplify and combine completely? And then did I factor completely and cancel out? So that is that problem. Any questions with it? Okay. So the next thing we're going to work on is still an example 11. Okay, now we're going to work with, if we just did one that had two of the same denominators, what do you think this example is going to be?
Different denominators.
Very good. It's actually a simple one with different denominators because the next one is a beast. Okay. All right, so the way, if you are, that's a 3, by the way, not a messed up 2, it's a 3. If you guys are going through and looking at the slides, which is completely fine, you may totally do that. They just kind of take things a little bit more broken down than I do. And I feel like since you guys are so used to how I teach, it may end up being confusing to you or looking like it's just too much. I don't really like the way they do it. I like asking my questions better, so we'll just go with it that way. So the first thing we have to look for is the lowest common denominator. All right, because we obviously don't want to spend extra time going through and canceling out if we don't have to. So 6 and 4, what's the lowest thing they can both go into? 12, perfect. Okay, and we have an x and an x cubed. We're just going to go with the higher one, right? So your LCD for this whole term, whole set of terms, is 12x cubed. So what you're going to ask yourself next is, what is missing? Missing, apparently. But what is missing? All right. So to answer that question, you're going to look at 6x and you're going to compare it to 12x cubed. What do you need so that those are the same things? Like, what piece of that common denominator are you missing that you don't have for the first fraction? And that's what we multiply on top. So obviously, to go from 6 to 12, we need to do what?
Multiply by 2.
Yep. And to go from x to x cubed, we're multiplying by what?
X squared.
Mm-hmm. All right. So now that we have that, the 6x basically disappears. Okay? Because on the bottom is just going to be your common denominator. So the next question is what do we have missing here? So to go from 4 to 12, what do we need to do?
Multiply by 3.
Mm-hmm. And we already have our x cubed, so we don't have to do anything else. So that's it. We've brought it together, and now we just need to simplify and cancel out if we can cancel out. So 5 times 2x squared will give us 10x squared. 9 times 3 gives us 27 over 12x cubed. And that is your final answer. Okay. Now, if you don't like my approach to that, you may by all means look at the slide. I am telling you we did that in what, 3 steps? Not that I really care. You can take extra steps. But I feel like I think the slide takes about like 2 complete slides to get to it. I lost track of how many steps they took. All right. Any questions on that style? We will obviously go through more of them. The next one is a little bit harder. Right. All right, so example 11. And this is technically an example of a sum function. Which is kind of funny when you think about it. All right, so we're going to let f of x equal 3 over 12x cubed minus 22x squared plus 6x. And then g of x is going to equal x plus 1 over 30x squared minus 10x. All right. The first thing they want us to do is they want us to find f plus g. And then the second thing they want us to do is once we have that function, they want us to evaluate it at 2. Okay. So first things first. We have to find our LCD. So before we can find our LCD, we have to factor, right? We have to know what we have to work with. Because right now, can someone tell me what my LCD would be? No. So when you bring these down to add them, you can actually go ahead and factor at the same time. Ow. So g of x is actually a little bit easier to factor first. So we're going to pull out a 10x. And then we're going to have left x minus 1. All right. And then the second one, you can pull out a common factor of 2x. So pull that out. And then you're going to end up with x squared minus 11x plus 3. But that can actually be factored. So we get 3x minus 1. Oh, what did I forget over here? Forgot a 3. Did anybody catch it before I said it? I bet you did. You're all really smart. All right. Here's my hint to you. Especially when doing problems like this, and I'm saying like on Pearson on an exam, if it's blatantly obvious that this is the type of problem it is, 9 times out of 10, maybe even a little more, you will have the easier factor show up in the harder factoring. Does that make sense? So like, if you didn't know where to start for the f function in factoring, other than you pulled out a 2x and then you were just staring at it and you were like, I don't know what factors to try this factor first, because more than likely it will help you. Okay. All right. So now that we have that, we can pull out and figure out our LCD. So for this case, it's going to be a 10x. Three x minus 1 and 2x minus 3. Right. Why did I not include the 2x? Or better question, did I include it and you just don't see it?
It's included in the 10x.
Very good, it's included in the 10x. Why? Because 2x times 5 will give you 10x. We could have broken down this 10x. In fact, that's what the slide does, but I just feel it's not necessary. All right. And again, if you guys need any further explanation, please let me know. I will obviously go into detail if you need me to. All right, so this is the part where I always like to say, and you're going to hear it a lot, what's missing? Okay. So this is that step. So right here we have 2x, 3x minus 1, and 2x minus 3. Well, we have 3x minus 1, we have 2x minus 3, we have an x, and we have a 2. So what's the only thing missing? We don't have a 2 in a 2 by itself. So how do we go from 2 to 10?
Did you multiply the bottom then divide it?
What do you mean by that? We're still
Like-
gonna have a bottom. I'm just trying to help you guys set up the top.
Oh, my bad. I'm confused. Like, did you take the bottom and then just like combine the numbers to get like the numerator then?
Right, that's what we're working on doing. So what we want to know is, so right now this is your bottom that you have, right? And we want to compare what you have to where we want to be. This 10x times 3x minus 1 times 2x minus 3. That's where we're trying to get to, okay? So the question is, from where you're at right now, what's missing between those two? For just this fraction, what's missing? And if you have to, you can cross them out like while you're looking at them. So you have a 2x minus 3, right? You have a 3x minus 1. You have an x. And then you have a 2. So how do I go from 2 to 10?
Multiply by 5.
Perfect. Okay. All right. So because we did that, we can now write it as one fraction. But the next thing is what do we have missing here? Here we have a 10x and a 3x minus 1, but what piece is missing?
Two x minus 3.
Mhm. as you work with these more, you're going to get quicker and quicker at them. In the beginning, you do have to figure out where things are coming from. So definitely work on figuring it out, work on seeing those missing pieces. It's very important. Okay, so the next step we're going to do is we're going to go ahead and simplify and combine like terms. So when we FOIL the right side here, what do we end up getting? Okay. All right. So then your overall answer becomes 2x squared minus x plus 12 all over your denominator. Any questions with that kind of problem? Okay. And I promise you these are going to be the chapters. Remember how like we were kind of steamrolling through chapters 1, 2, and 3? We like did those super fast, and then like 4, 5, or 4, 6, and 7. You know, we took our time with them, but they were pretty quick. These are the beast. You have entered the dragon's lair. Okay. If you have a hard time with it, just ask me questions, because once we do this, you know, it's basically done. These are the last chapters. You will have successfully completed 105. All right, so now once we have this for part A, part B, or number 2, they want you to plug in for 2, but I have a feeling we need to kind of make some more space. So I wish I could just, can I just keep this? That would be so nice. Probably not. Oh no, I just saved it twice. Oh well. All right. So now that we have f plus g, now we need to do f plus g of 2. So what are you guys going to do to finish that? We're just going to do what?
Plug 2 into the equation.
We're going to plug 2 into the equation. Very good. So everywhere you have an x, you're going to put a 2. And just because I'm doing an evaluation, I like to always use my parentheses. You don't have to. I'm showing it to you that way on purpose, but if you are okay with what you're doing, then you don't have to do it that way. 2. Okay. You work everything out and you end up with 18 over 100. It works down to 9 over 50. Try very hard to remember the simpler math when doing this. Like, you know, when to simplify, when to cancel things out. Because once your brain has done all the harder, higher math, and then you get to this point and you forget to simplify, you know, you can get frustrated if you have to do it again. All right. I don't think you'll have questions on that because we've done it a handful of times now. All right. Okay, moving on. Example 12. Right. Example 12 is it's a difference. Wow, I'm just not even gonna go with that word because having a hard day apparently with everything, words and spelling and talking, so. And it's only 11:49 in the morning. All right. Somebody tell me what you kind of like about this problem.
You can cancel out the bottom.
Kind of. So the bottoms look very similar, right? And there's a reason for that. That's why they made it this problem. So we're gonna have y over y minus 2. And then remember when we pulled out a negative before? We can pull out a negative again. So then what do you notice about your denominators? Are they the same or different? They're the same now, right? Okay. So instead of a minus between them, we're actually going to have a plus, and we're just going to bring everything together. So y plus 3 over y minus 2. And that's it. Okay. All right, so for number 13, we're going to be adding and subtracting. It is three rational equations in one. So I don't think I've used this blue before. It's very nice. All right, so we're gonna have x plus 2 over x squared minus x minus 6 over x squared minus 1 plus 3 over x squared plus x. It is very important when you're going through and doing these problems that you double check all of your signs. Because we're basically working with different mini problems within the bigger problem, if you end up having a sign error, it can super mess up your whole problem, which will eventually just mess up your whole day. That would suck. All right, so the first thing we're going to do is we're going to go through and factor so that we can try to figure out our lowest common denominator. I would like someone in the audience to tell me what you think your lowest common denominator is.
Is it just -1 or no?
So, Teddy, I want you to look at each individual denominator and tell me what you see that we can pull out as being common, or what you, I guess each of the pieces, tell me what one of the pieces are.
I mean, is it just +1, I guess? Or
So we're allowed to keep the X's. So I want you to look here, here, and here. We're gonna try to combine these, okay? So tell me just one piece that you think will be in our denominator.
X minus 1?
Yep, X minus 1 is gonna be there.
And X plus 1?
You're rolling with some steam. You just need one more piece.
And then is it X squared?
Super close. So it's just going to be our X. Okay. But I see how you got that. All right. So thank you, Teddy. So that is our denominator. That's our lowest common denominator. And now we have to go through and we're going to ask my famous question, right? What's missing? Okay. So we have to figure out what's missing in each piece. So if we compare our X minus 1 to our new denominator, what's missing?
X plus 1.
Excellent. Okay. Middle piece. We have X minus 1, X plus 1. What's the only piece missing?
X.
All right. And the last portion, we have an X and an X plus 1. So what piece is missing?
X minus 1.
Right. So now we're just going to rewrite your LCD. Now, sometimes it's completely up to you, and I'm a total fan of it if you're okay with it. So sometimes when you're going through these problems, instead of writing the LCD every single time, you can wait and write it in the last step. Totally up to you, but it also depends on how you do your comparisons. So I don't have a lot of room, so I'm just going to write LCD underneath it, and then I'll probably do it again for the final, but you should always write it out for your final answers. In fact, there's going to be a reason why, so we will have to. All right. So we're going to go through and we're going to FOIL, then simplify, then see what else we can do. So if we FOIL the first part, what are we getting?
X squared plus 3x plus 2.
Very good. Okay. And then we'll have a minus 6x. And then we'll have a plus 3x minus 3. So if we simplify just that piece, we end up with x squared minus 1. But what can you tell me about x squared minus 1?
It factors into x minus 1, x plus 1.
Now somebody take a look at what our LCD is. What's our LCD up there?
X and then X minus 1 and X plus 1.
So what do you think we can do?
Take those out.
Yep, we're going to cancel x plus 1 and we're going to cancel x minus 1. So your overall answer is 1 over x. And I just realized that I basically have a political mathematical problem on the board. I don't know what the pink is. Maybe that can be the new color for the independent party. Any questions on this problem? Okay. I think I saved it. All right. So we are going to look at example 14. Right? And this is actually called a difference function. Okay, so it's very similar to the sum function we did. We're going to let f of x equal x minus 1 over x plus 1, while g of x is going to equal the opposite, x plus 1 over x minus 1. And just like before, they want us to find f minus g. And then once we do that, they want us to evaluate it at 5. Okay. So here's my question. What do you think your LCD is? We want to combine these two fractions.
X plus 1 and x minus 1.
Here it is. Okay. So now we have to ask what's missing. So you had x plus 1. What's the part that's missing? It's the x minus 1, right? Okay. And you had x minus 1. And now it's the x plus 1 that's missing. Okay. All right, you have to remember, and this is very important, you have to remember that you're subtracting out all of the second part. So you have to do this foiling and simplification of this part before you can do your distribution of the negative sign, okay? Has to be done that way or you will get the answer wrong. All right, so when we FOIL, we get x squared minus 2x plus 1. And then we get x squared plus 2x plus 1. All over our LCD. Which means we get what? The x squares, they're going to cancel, aren't they? So x squared cancels. 1's cancel. What do we have left?
Negative 4x.
There you go, negative 4x over our LCD, x plus 1, x minus 1. Okay, are we done? Did we answer the complete problem? We answered it for number 1, right? Now we have to go in and evaluate it. So we're going to do f minus g at 5. Okay, so now what do we just have to do?
Plug the 5 in for x.
Mm-hmm. Okay, so you end up with negative 20 over 24, which gives you negative 5 over 6. Again, if you wanted to give me the decimal, I don't really care. You can give me either one. Doesn't matter. All right. 15 and 16 are pretty lengthy. So let's give them a go and see what happens. How long we make it to. Okay, so for example 15, we're going to practice two different methods. The example in 15a, you're going to consider that method 1. If you can come up with names for them, that's cool. If not, there may be names that exist for them. The one I think is multiplied by a special 1, which is LCD over LCD. And then this one is just kind of using your fraction rules. So when you divide a fraction by a fraction, what do we typically do? Ignore the fact that there's a bunch of things you don't like about this problem and tell me just what you normally do when you have a fraction divided by a fraction. I know you know this answer.
Multiply by the reciprocal.
There you go. So if we have 8 over x cubed, what is the reciprocal of 8 over x cubed?
X cubed over 8.
There it is. And then now we can go through and cross out and simplify. So the 3 is going to become a 2. So x squared. 8 and 12 become what?
Three and 2.
Perfect. Okay. I will tell you that you will like method 1 1,000 times more than you will like method 2. But unfortunately, method 2 is sometimes just makes a little bit more sense to use. Now, of course, we're not going to use the same problem to practice method 2. That would be too nice. Instead, we get to use this really gross problem. Okay, so the first thing I did is I did use the, oh no, this is also method 1. I'm sorry. 16 is practicing method 2, which is why you will like this method better. Okay, so the first thing we're going to do is we're going to use our definition, x squared minus 9, x squared plus 2x plus 1. Now, if you're working a little bit ahead or you're a little bit quicker than other people, you may certainly choose to factor at this point, I'm not going to stop you, but I'm not going to do it yet myself. So I'm also not going to flip my reciprocal yet. But we all know that it's going to be the same process, okay? So you keep your first one the same. And then we're going to flip the reciprocal. Okay. All right. So now we can go through and we can factor. So somebody factor for me x squared minus 9. Excuse me. And if you don't want to factor that one for me, you can always factor another one. There are 4 things that need factored.
The top one, it's x plus 3, x minus 3.
There you go. Got anything else for me?
For the denominator, it'd be x plus 1 and x plus 1.
There you go. What's next?
The second fraction would be 2x minus 3 over 4x plus 1.
Right. I'm not going to reduce it just so everyone can see it, but you are totally correct. Okay. So once you've done this step, once you've factored every possible thing you can factor, the next thing we're going to do is go through and cancel out what can cancel out. So our x minus 3s, they can disappear. Our 2 and our 4 can just become a 2 left over. Now, x plus 1, we have 2 x plus 1s on the bottom, and we only have 1 x plus 1 on the top. So what do you think that means?
Only one set cancels out.
Correct. Only one set cancels out. Please don't tell me or think you can tell me that because there's a 2 out front here, that means there are 2 x plus 1s, and then you can cancel both of them. You will end up with an incorrect answer. Please don't do that. All right. So we're going to end up with 2 x plus 3 over x plus 1. Now, you, by all means, I'm 90% certain with Pearson, you can go ahead and either put that answer in like that, or you could go through and distribute. I will tell you that when I was a student, I used to get so confused as to why my teachers would be like, okay, you can leave it like that. But then in other cases, they would be like, no, you need to distribute and you need to combine and whatever. If you go through and distribute, your answer will not be wrong. However, I am giving you the warning that you can only simplify on the top and simplify on the bottom. You cannot simplify any more up and down because you're in the lowest terms you can be in, okay? So don't think that you can cancel out. And if you could cancel out, you would already have canceled, okay? I would leave it like that. Having been now on the teacher side for a very long time, I can tell you that the reason why other teachers tell you to leave it like that is because now you can see it's all nice and neat. You see where all your factors came from. Nothing else can cancel out, and you have no other questions, okay? That just wasn't told to me when I was a student, so I would get kind of, what's the word? Not defensive. What's the other thing when you like have an issue with authority figures? Whatever. That's me. So defiant. I would be defiant. I would want to just keep distributing because I could. All right. So that is our second to last example for the day. We are going to go now into example 16, which is going to be talking about the second method. So we're going to practice method number 2. And this is basically where we're going to multiply by the LCD over the LCD. Now, here is the big warning. If I had neon lights behind me, I would have them go off, but I don't. When you are working with this kind of problem, we are going to take the LCD of all 4 denominators, okay? You cannot do multiplying the LCD of the top and then the LCD of the bottom. You will get the problem wrong. It has got to be the total lowest common denominator of all of the pieces. Make sense? Okay. Whew. All right, we have 1 over y squared plus 3 over 2x over 2 over y minus 1 over 3x. Okay. So our LCD, you have to look at y squared, y, 2x, and 3x. So if we look at all those together, 2 and 3 will give us what? What's the lowest thing 2 and 3 go into?
6.
We have an x, and the highest y we have is y squared. Okay. That is your overall LCD, all right? So what we are going to do is we are going to distribute this LCD to each one of the fractions. So 1 over y squared times 6xy squared plus 3 over 2x times 6xy squared. Now, if you are seeing this quicker than other folks, that is fine. You can go through and do some of the steps quicker and together and whatever. But for right now, we're going to take it one step at a time. Does doing it this way kind of help you see what you're missing a little bit better? Okay. If that is the case, you can certainly do this in a way in the other problems, but I feel like it's easier not to, but that's me. So what we're going to do is we're going to go through and cancel out what's common so you can see what's left. Okay, that should help some of you guys a lot better. And this process is the same that we just did. It's just kind of really jam-packed in there. So you have to really know what you're doing. All right, so 6x plus, and then we have 3 times 3y squared. So that's going to give us a 9y squared over 2 times 6x, which is 12x. And then minus 1 times 2y squared, so 2y squared. Okay, now if you would like, you can go ahead and factor. We're going to pull a 3 out and be left with 2x plus 3y squared over 2 6x minus y squared. You might be able to get away with putting the first one into Pearson. The second one would definitely go into Pearson and be okay. Oops.
In the denominator, shouldn't it be 12xy?
Good job. Okay. So that makes that a y. Good job. All right, so there's not really a true reason for why you need to go ahead and factor that out. The only reason I can tell you is if you get into the habit and you are able to cancel something out, then this is the step you would be able to see it in, right? Okay. If you leave it like this, side, then obviously we don't know if there's something that could get canceled out or not. Or you might think there is, but there really isn't. So if you go ahead and factor, then you'll know for sure. All right. Okay.